What's up, everybody? It's Miss Ortiz here, and welcome to what I recommend to be your first module, Generating Electrical Power. There are 8 total slides in this presentation, so what I'd like you to do right now is to take a second and make sure that you have a timer set. Let's get started. Make sure that you take a second to record this driving question in your notebook, whatever page comes next. The driving question for this module is, how is energy from burning fuel turned into electricity? We're just talking about one kind of generation of electricity in this section. There's a couple different kinds of solar power that we'll discuss later. And wind turbines pick up after a part of this process, so they're not the entire process here, but some of the stuff they do is really similar, and we will talk about it here. Okay, so I'm sorry you can't see me, but if I show my camera here, then you're gonna not be able to see the whole thing. At this point in time, you should have your driving question written down. And now the next thing you're gonna do is create this graphic organizer in your notebook. Don't get too fancy, don't make it too big, or you're gonna run out of time. We still have 5 slides left to do. Go ahead and pause this now to take care of that. Okay, so the way we can think of energy comes in many different kinds of forms. And energy can't be created or destroyed. It can only be converted from one kind to another. When we think of energy, we can think about it in 2 major buckets. The first bucket is that which is called kinetic energy. That's anything that comes from movement. So there's many different kinds of ways that we can create kinetic energy. The other way we can think of energy is as stored energy or potential energy. It's energy that can be used later. And what we're going to be doing in an electrical generator is we're going to be converting one kind of energy to another. So when we feed a fuel to a nuclear or to a generator in general, we are going to take the chemical potential energy that is locked up in those bonds of the molecules that are in the coal, in the natural gas, or whatever. We're going to use them to create thermal energy or heat. That thermal energy is going to be used to drive a turbine, and we're converting thermal energy into mechanical energy, the energy of any object in motion. The mechanical energy of the turbine is going to drive the generator itself, and that's going to create our electrical energy. All of these things are considered parts kind of kinetic energy, but if you think about it, electrical energy could probably fit in either of these 2 buckets, kinetic or potential. The last thing that I really want to focus on in this module is nuclear energy, the energy that is stored in the nucleus of an atom. The nuclear energy is what we're going to be using to drive the generator in a nuclear power generator. But we're going to talk about that way more in a following module. The things that we probably won't talk about that much in this particular module are going to be magnetic energy, chemical energy, elastic energy, and gravitational energy. But I do still want you to know what they are. What you see here is a really simplified version of an electrical generator. You can see that there is a turbine that moves through a magnet. The magnet drives the coil, and the coil is what winds up generating the electricity. This is a really simplified version of what you would see in an actual generating station. But what matters is that the turbine in a real-life generating station is driven by hot, pressurized steam. So if we're burning coal or natural gas, what kind of conversion energy are we converting into what kind of energy? Take a second to think about that. Write it down in your notebook. What kind of energy are we converting into what? Yes, when we're burning coal or natural gas, we're converting thermal energy into mechanical energy, and the mechanical energy is converted into electrical energy. And that all comes eventually from the chemical potential energy of the bonds in the coal or the natural gas. In a nuclear generating station, you're not actually burning anything. I say that you're burning it, but it's not actually burned. We're unleashing the energy of the nucleus of an atom when it falls apart, that generates enormous amounts of power, and that's what's going to create our steam. So what is happening when we're creating energy, or when we're creating electricity from a nucleus of an atom? What kind of energy is being converted into what? Nuclear energy is being converted into mechanical energy, and then that mechanical energy is converted into electrical energy. So the last thing I want you to think about is where wind fits in all of this. We're not burning anything, so what happens? Mechanical energy is being converted into electrical energy when you have a wind turbine moving. So it's basically the same idea. It's just in wind power, we don't have to burn anything to get a turbine to move. So at this point in time, you've done the fill it in the blanks for this specific activity. I don't want you to copy the entire thing down in your notebook, but I do want you to pause here and see if you can summarize this in your notes. Check your timer. I highly encourage you to watch the upcoming video if you have enough time left. It's about 9 minutes long. If not, skip it for now using the blue arrow in the Nearpod, and I'll put the link in the resources thread of our class team for you to check out. Have a look at your notebook. At this point, you should have definitions of the types of different energy and a summary of how a power generating station works. The other thing you should have is a basic idea of what types of energy are being converted into what when you burn a burnable fuel, when you use nuclear power, and when you use wind. The last thing that I want you to do is to try and summarize or answer the driving question. How is energy from burning fuel turned into electricity? Summarize whatever answer you have in your notebook, and then move on to the next slide where I will ask you to type your thoughts out so I can see what everybody thinks. This is going to be the last thing you hear from me, and you should have your own version of this answer. So to answer the driving question, what I would think about is this. Energy from fuel, the chemical potential energy from fuel, is unleashed to create steam. Then I have steam or wind driving a turbine and a generator and being converted into mechanical energy. Then lastly, mechanical energy is converted into electrical energy and transmitted all across the city or the country. That's going to be it from me. I hope you have a wonderful afternoon and a great productive day working on the rest of your tasks.